In this question, we're told that at time t equals 0, so at the beginning of our observation, a small stone is thrown vertically upwards with speed 14.7 from a point A. At time t equals t seconds, the stone passes through A, moving downwards. The stone is modelled as a particle moving freely under gravity throughout its motion. Using the model, find the value of t, so capital T, the moment when the stone returns to point A and is moving downwards. Okay, a quick diagram. We know it's being projected upwards, but we don't necessarily know that it's being projected from the ground. I'm just going to draw it from a platform. So here's the stone, point A, and this is the flight path. Initial direction is moving up. We need to find at what time it gets back to A and is moving downwards. Well, if it's returned to its starting point, we know the displacement is going to be 0. Let's collect some SUVAT variables. Displacement is 0. Initial velocity we were given, 14.7. Acceleration, negative 9.8. That's the acceleration due to gravity. And we're looking for t. So that puts us in a situation to use s equals ut plus half at squared. Substitute those numbers in. We have a quadratic. Solve the quadratic for t. You can factorize. You can use the quadratic formula. You can use the equation solver on your calculator. Either way, we get two results. T equals 0 or t equals 3. We know we're not interested in t equals 0. T equals 0, yes, it was at point A, but this was at the point of projection. We're looking for the time when it returned to A, not when it was initially at A. So, t equals 3, that's the result that we want. Part B asks us to find the total distance travelled by the stone in the first 4 seconds of its motion. The first 4 seconds. The total distance travelled by the stone. Okay, so we know at 3 seconds it's travelling downwards at point A. So at 4 seconds, we should expect it to be below point A. And we need to try and find the total distance. This is one of those questions where finding the displacement alone is not going to be enough because the particle's moved up. So here's displacement 1. It's done that twice. And the answer to the displacement after 4 seconds is going to be S2. So I need a combination of two S1s and an S2. The journey up to the highest point, from the highest point back to the projection point, and then how much further does it go below in the last second. Let's collect some SUVAT variables. First, I want to find S1. So what is the distance to the highest point? We know the velocity at that point is 0. Initial velocity was given to us, and once again, acceleration due to gravity. Let's put this all into the correct formula. V squared equals u squared plus 2as. Substituting in our numbers, 0 squared, 14.7 squared, 19.6. Rearranging, we get a displacement of 11.0. So, from projection to the highest point is 11.0. From the highest point back to the point of projection, another 11.0. Let's find S2. So, we know this is the displacement after 4 seconds. Collecting the correct SUVAT variables, unknown displacement, 14.7, acceleration of negative 9.8, and we set time equal to 4. This is the formula to substitute into. As we substitute, we get a displacement of negative 19.6. Okay, so our total distance travelled is going to be a combination of two S1s and an S2. So S1 plus S1 plus S2. 11 plus 11 plus 19.6, 41.6. The total distance travelled, 41.6 meters.